All right. Quiz 12. Study guide. All right, number 1 in the short answer. Lee went for a mountain bike ride in a relatively flat wooded area. You got to keep in mind these questions. We've talked for 2 or 3 days about triangles and the lengths of sides of triangles. So when you get one of these questions that doesn't really refer to a triangle, be sure that you're thinking triangles. All right? She went for a bike ride. She rode 6 kilometers in one direction, then turned and pedaled 16 in another. Finally, she turned in the direction of her starting point and rode 8 kilometers. When she stopped, was it possible that Lee was back in her starting point? So, if this was her starting point, all right, starting point, and she rode 6, and then she turned any direction, doesn't matter what direction she turned. Best case scenario for her would be if she turned and went straight back to her starting point, right? But if she did and she went 16 kilometers, she went this way, 16. And then it said she rode 8 kilometers. Is it possible for her to be back at the starting point? Okay? Is it?
Yeah.
It's not. I'm sorry. It's if you go 6 one direction, and this is not to scale, okay? If you go 6 one direction, and then you go back 16, think about it. If you're right here and you go this way 6, and then you go this way 16, aren't you still 10 away? Because the 10 plus the 6 is the 16. Okay? So this is a case where no. She could not be back at her starting location, no matter what direction she turned each time. Number 2, what is the range of values for x? So here's your picture. And I wouldn't draw the picture again on your notes. I would just do the work that I'm getting ready to do in your notes. It'll save you a lot of time. We got ABC. And AB is congruent to BC. Both triangles share side BD. So we did these problems yesterday. You've got this angle that's represented by 4x plus 8, and it's across from a 32. And then you've got an angle that's 48 degrees, and it's across from a side that's 20 units long. So the 48 degree angle has to be less than the 4x plus 8 angle. So you've got 48 that's less than 4x plus 8. Now, you're looking for a range of values, so you need a top limit on your range. Since this 4x plus 8 is greater than the 48, it has to be less than something. And if it represents one angle in a triangle, it has to be less than 180 degrees. So that's your compound inequality. And you solve that by subtracting 8 from the middle and the right and the left. So 40 is less than 4x, which is less than 172. And then you divide everything by 4. So 10 is less than x, and x is less than 43. So there's your range of values for x. All right, number 3, they give you 3 pieces. Can these three segments form sides of a triangle? You got piece B. I'm going to go down here, piece A. And then you got piece C. Can they form a triangle? B and C aren't long enough, are they? If you took B and you put it right here, it's only going to go to there. And if you took point or segment C and you moved it straight down and started it here, it's only going to go to there, isn't it? So could they form a triangle? There's no way. Even if you went here, it's not going to work. B and C aren't long enough. B plus C has to be greater than A. So this is another case of no. And you could say that B plus C has to be greater than A. Oh, not 8A.
I don't know why 0 could throw off.
Here. Alright, number 4. Two sides of a triangle have a length of 10 and 15. What must be true about the length of the third side? Okay, so you're given a 10, you're given a 15. What must be true about the third side? In this case, you're going to take your 10 plus your 15, and that equals 25. You're going to take your 15, and you're going to subtract 10, and that equals 5. So your range of values for the third side must be between 5 and 25. So the question is, what must be true about the length of the third side? You can say the third side must be between 5 and 25. And if you want to shorten that, you could also say that 5 must be less than x, which must be less than 25. Number 5 is just like number 2. What is the range of possible values for x? The diagram is not to scale. Alright, you're comparing this 2x angle to the 54 angle. The 2x is across from a 22. The 54 is across from a 30. So the 2x is across from a smaller number. So it's going to be less than the 54. So 2x must be less than 54. If the 2x is less than 54, it's got to be greater than something. And now, since it represents an angle in a triangle, the last time we set this up, it had to be less than 180. Now it has to be greater than 0, because this angle in the triangle needs a measure. So, to divide by, or to solve for x here, you divide everything by 2. So 0 must be less than x, which must be less than 27. So there's your range of values for the third side. In number 6, you've got two triangles. SRT and BCD. Alright, you've got two triangles with two congruent sides. This is your Hinge theorem. You've got a 10x that's across from an 18, and you've got a 6x plus 20 that's across from a 14. You're trying to find the range of values for x. So the 6x plus 20, since it's across from a 14, it's going to be less than the 10x because it's across from an 18. Alright, now when you're writing these compound inequalities and you have variables on both sides of the inequality, you have to write two separate inequalities. Okay? You've got your 6x plus 20 that is less than the 10x. Alright? So now your 10x has to be less than something. And since the 10x represents one angle in the triangle, your 10x has to be less than 180. So we're going to solve this equation on the left first. We're going to subtract 6x from each side. And 20 is going to be less than 4x. And then divide both sides by 4. So 5 is less than your x. Now we're going to solve the other equation. Divide both sides by 10. And x is less than 18. So now that you've solved both equations, you're just going to combine them into a compound inequality. So your 5 is going to be less than x, which is less than 18. There's your range of values for the third side. On your essay number 1, two doors are 36 inches wide. Door A is open to an 11-degree angle. Door B is open to a 62-degree angle. Which door's outer edge is further from its closed position? Justify your answer. That's just like the two doors we looked at yesterday. Okay? You got two doors that are the same size. If one is open to 11 and one is open to 62, isn't the 62 opened a lot more? Okay? So which door's outer edge is further from the closed position? That's going to be door B. It is opened further. Alright, then we got 6 multiple choices. Number 1 on the multiple choice. Two sides of a triangle have lengths of 7 and 15. Which inequalities represent the possible lengths for the third side? So again, you take the two sides and you add them together. 7 plus 15 equals 22. Then you subtract them. 15 minus 7 equals 8. So your 8 has to be less than x, which is less than 22. In number 2, Which of the following must be true? So here's your triangle on the left. And your triangle on the right. You got two triangles with two congruent sides and included angles. Alright? 25 is across from side AC. 77 is across from side FH. This is just like the door problem, right? Isn't the door on the right opened way more than the door on the left? Okay, so AC has to be less than FH. And understand that another way of saying this would be that FH is greater than AC. Those both mean the same thing. Okay? Both of the inequalities are pointing towards the AC. So they mean the same thing. Number 3. Two sides of a triangle have lengths 6 and 17. Which expression describes the length of the third side? So you add them together first. Your 6 plus 17 equals 23. Then you subtract. 17 minus 6 equals 11. So your third side, 11 is less than x, which is less than 23. But now the wording is new. Answer choice A says at least 11. Answer choice A says at least 11. Well, if I told you at least 11, doesn't at least 11 include the 11? At least includes the 11. Can the third side include the 11? Cannot. So it's not answer A. Answer B starts with at least 11 as well, doesn't it? So it's not, it can't be answer B. Answer C. Greater than 11, that works, but it also says at most 23. At most 23. Doesn't that include 23? But it can't be 23, can it? It's got to be less than the 20. So it's not answer choice C. And then D, greater than 11, less than 23. Yes, that's exactly what the inequality says. Okay? So the at least includes this number, and the at most includes that number. We're not looking for that. Number 4, folding chair problem. Folding chair can be set in different positions that change the angles formed by its parts as angle 1 increases. So let me try to draw this. You've got it on your paper, but here. Oh boy, I didn't draw this very good. There's your angle 1, right? Alright. As angle 1 increases, how does the relationship change between the back of the chair? Alright, here's the back of the chair. And the front leg of the chair. Here's the front leg of the chair. So as this angle, angle 1, and once you see this and you identify the angle and the two legs, just picture a folding chair, right? Have you guys ever unfolded a chair? Well, as angle 1 gets bigger, what happens to the green and the yellow? As you open the chair. It's a folding chair, so when this thing is closed up, it's going to look like this. I mean, it's going to scrunch up to nothing. It's like an accordion. So when you open the chair, what happens to the yellow and the green? They get further apart, don't they? Okay, as you unfold the chair or open it further, they get farther apart. All right, and as you close or fold up the chair, as angle 1 gets smaller, green gets closer to yellow. As angle 1 gets bigger, yellow and green get further apart. Okay? Alright, I apologize for the... It's not horrible, but it's pretty bad. Alright, number 5. Be careful when you're reading this. I would highlight that word cannot. Which 3 lengths cannot be the lengths of the sides of a triangle? So we're saying cannot. You got A, 23, 17, 14. Alright, you take the 2 smallest sides and you add them together and you subtract them. So 17 plus 14 is 31. Let me move this over. (17 plus 14 is 31. 17 minus 14 is 3. Third side has to be between 3 and 31, and this is. So it would be a triangle. Answer 2, 11, 11, and 12. If you add the 2 smallest sides together, you get a 22. If you subtract the 2 smaller sides, you get a 0. The third side is in between 0 and 22, so that would make a triangle. 5, 7, and 8. If you add the smaller sides, you get a 12. If you subtract the smaller sides, you get a 2. The third side is between 2 and 12, so that would make a triangle. It only leaves one choice. Alright, but let's do the math anyway. We got a 21, a 6, and a 10. Well, 6 plus 10 is 16. And 10 minus 6 is 4. Well, this third side is 21. It's too long, isn't it? Alright? So, since this one would not make a triangle, and you're looking for the legs or the lengths that cannot, there's your correct answer. Answer D. Alright? Now, I'm not going to go through that again on number 6. Just be careful on number 6 because it says which 3 lengths could be the lengths of a triangle. So you're going to do the same thing, right? But you're just going to choose the 3 lengths that would make the side of a triangle. Alright, well here, let's just do it. We got some time, and you could use a little more practice. So we're looking for which could. Answer choice A. 12, 5, and 17. Alright, the 2 smallest sides added together are 17. And subtracted give you a 7. Is the third side between 7 and 17? It's not. So that won't work. 10, 15, and 24. Take the 2 smaller sides and add them together. 10 plus 15 is 25. 15 minus 10 is 5. The 24 is the third side. That would work, wouldn't it? That would work. Now, before you choose B and write it in the answer sheet, just scan the rest of the answers and make sure that answer D isn't something like B and C. Okay? It's not. So you're done. B would make a triangle. And that is Quiz 12 Study Guide.